In this model editor video, you will see how I will be using the XLfit model editor to create a custom statistic that in this particular case will be generating a sine wave. So what you can see in front of you at the moment is an Excel spreadsheet with a range of columns A through to D which have been populated, and a column E which is expecting a sine function. There is no formula or function that you can use to generate this that is provided in the traditional statistics set. So this is something that we would actually want to add to this list of statistics. So I have my own custom function that I would like to plot. So I have this here and in memory, and I'm going to create a new statistic to allow us to calculate this. So I select statistic from the model editor, and what I'm doing is I'm editing the model that is built into this version of this user's Excel. So I can create a new category, wave functions, demo, which creates a new element of the hierarchy, and I can embed my statistics underneath here. So let's add a statistic in. It creates this dialog which shows you what you need to do. You need to create a name and a formula, so let's call it demo wave sine wave for a demonstration. And this is the formula that I wish to use. I'm just going to modify this formula. Notice how I typed in this formula, pasted it in this case. It determined the four data parameters that we needed for this statistic. Let's make them very easy to understand. So we have the amplitude of the wave, we have the time series, the shift, and the frequency. And as you can see, as you've typed in those parameterized elements, it has determined that these are the data elements for this statistic. Creating that, I generated my formula in here, and that is now available in the model file that is loaded into XLfit. So if I go to Statistics Designer, and I go to Models, I can see there's now hierarchical wave functions, demo sine wave, and I can go in and add the values according to the corresponding places for this particular set of data for this model. That generates me a particular sine wave. I will also show that you can see the ranges that have been selected, and you can change these formulas in a normal way. So in this case I'm going to press F4 several times and make that an unlocked Excel formula, which allows me to do the following. Drag down and apply the formula to the range of data that are there, overwriting anything that is currently in place. So now I have a set of data, a sine function, that has been plotted into Excel. So having plotted our data using a custom statistic, what we want to be able to do next is be able to represent this on a chart, and that requires us to create a fit model inside of the model editor. And in the same way as I did earlier, I've created a category within here. It's within here that we'll create a formula. Now the key things are that formulas have to be represented for fits in a certain way, with the X and Y for the corresponding models labelled accordingly. So if I create a sine wave fit, and I give it my same function that I used before, where this is amplitude, and this is shift, and this is the frequency. Notice I will not be changing the name of X, as this is my X-axis for my fit, and I'll be leaving that in there. just as before, we can set the starting values for the ranges of the fit. So I will ask for this to resolve the best fit from starting from a value of 0 and iterating over different values. So I've created this new fit function called sine wave fit, and this allows me to see that fit inside of a fit designer. So if I create a new fit by opening fit designer, easiest ways with quick data setup, select the first 2 columns, select all the data, there we are. Here's our sine wave. We can see that it is not fitted at the moment, and we can find the best fit by running the best fit search, which will go through all the models in order, starting from the earliest model right to the latest, and you can rank these by, for example, chi-squared. And if we do that, you see that the one that I've just created is the best fit. And flicking through that visually, you can see that it is quite clearly the best model that's fitted. I can change the parameters of that fit, so I have a range of values that I have in my start sheet. I've got a shift of 0 here. The tool has found for me that it had a shift of 0.0097. If I wanted to change that to be exactly the same as I had used earlier, I can simply select the range and lock that, and that will apply and render differently within the sheet, and I can put that chart out to a particular range. So that's how you can use the simple model editor that is built into XLfit and is available for a scientist or anybody to edit their own models, create their own statistics for a function that they want to use. If you wanted to do this as an organization and you wanted to distribute your model files around your company, rather than using this model editor and changing it within each user's desktop, it is possible to do this in a single place using a deployed version of the model editor, which is a desktop tool. And the next video will cover how to use this. In this video, you'll see how to edit a model file and create a model file using the desktop version of the XLfit model editor. Now, this is designed to allow essentially an administrator to create and modify model files that they would wish for an organization to use. So this tool provides the same functionality as what was seen in the XLfit model editor that's built into the tool, but it also provides a number of other features that are used in more advanced purposes. So let's go through some of those right now. The first thing I'll show you is that there's some application options up here that allow you to change and set certain things to be true. And I've turned on the ability to show tests, the show test page, which will become relevant later on when I show some of the Unix tests. So if you don't see the unit test tab when you're editing these models, you need to set your options to show the test page as being true. Okay, so let's say you would like to open an existing model. You can open them in a number of ways. First of all, you can browse for it, and the standard models that come with the product are in model files folder, which is where we ship all of the models that we provide with XLfit. The ones that are defaulted to is called fit model open XML. If you open that, it shows you the name of that model file, its path, opens up and packs all of the models and presents them here. So this is where you can edit and change the behavior of all of the models that we ship, or add to them, or subtract from them if you wished. So in the previous example on my local machine I'd added another category under here, and it is just in the same way possible for you to add a category into an existing model file. So by right clicking, add in a new category. This will create a category around which you can add in statistics. You can edit these by double clicking on them. You can write equations, where you can define everything that you would wish to have here, all the parameters and display options that you would expect. To notice this test tab that I said I would come on to later. This is how you can edit an existing one, and you can also, of course, subtract models, categories quite easily by right clicking on them and deleting them. To take a model file, you can close these individual windows down, but they stay in memory. So if you wish to remove this model file, remove it from any tests or anything else that you wish to see, you need to unload this document from this model file pane. Let's create a new one. Let's create a fit model. Let's use our old friend wave function as a category. Let's call this as this. I notice it's red, so it's not happy with this particular function at the moment. And if I save this particular thing, I'm sticking on my desktop, call it fit document 3. You can see it's not happy, and you can see there's a directory of errors underneath here, and the reason is there's no residual. Double click puts you into an edit scenario where you can write our friendly function. You can write formulas in here. You can then set those things that are the residual, the fit, and you just write the formulas in here. As is appropriate. The next tab along is data. So you need to leave only those things that are actual data and move those things that are parameters. So I'm going to remove A, C, and W, which represent the amplitude, the shift, and the frequency. I'm going to leave X as my data point. Just as before, you'll be able to rename or type into these over these and change the names of these data points and parameters as you see fit. In here you then have quite a lot of control over the parameters that you've left that are not neither data nor part of the equation. So A, C, and W are my parameters, determine that. It also allows me then not only to set an initial value as you saw in the simple model editors, but to also use a prefit, to lock them by default, and set upper and lower boundaries to those values. So quite able to tune your parameters to the need of the formula. You can also set the display options for this and set this particular fit up to behave in a specific way. And you can create some tests, which I'll show you in a different example. So that's creating a fit. It's essentially the same functionality as what you saw, but with additional options and additional capabilities. Now I'm going to do a statistic, and I'm also going to run some unit tests against that statistic. Let's create a statistic file. as you saw, you can edit a model. And in the statistics model, it's a little bit simpler. There's no parameters, so we just need to have a result. Here's our old friendly formula again. Each of these defines data in a statistic, and you can create a unit test. So this is how you create a test. So let's say if I wanted to check that the formula hadn't changed between versions, or it was part of a process that you needed to validate that that XLfit was behaving as expected, you can add these tests simply by clicking right-click and add tests. It then determines all of these things that you can add values to, with these data fields. So the amplitude in our spreadsheet, if I just go back to the beginning, was 1, the frequency was 1, the shift was 0.01, and I'm going to pick a time series to check against. So let's pick a value of 1, an x value of 0.02, a shift of 0.01, a frequency of 1, and then I'm going to give it an expected result. So 0.02, this is our expected result. And I'm going to say, give me an exact result with no delta at all, to 12 specified places. Let's save our file with these tests in. And those tests run automatically once it reloads. And every time you open the model up, these tests are executed, and you can see that this document has failed, and it's complaining about the difference between the actual value it's calculated and the expected value you told it to look for. And the reason behind that here is a very small but important difference, is the number of decimal places that I've allowed. So XLfit is calculating a much more accurate result than the one that was shown in Excel. So I'd either need to change my original value, or I need to reduce the strictness of the test. So I'm going to say take me to 5 decimal places, and as you can see, it's much happier, and all the tests have passed. You can run tests on all loaded models just by going in here. That's a very simple test. If I was to load in a recent file such as all those fit models, and run the tests on that. I'm going to run one test because there's quite a few models there, and it will go through all those models and run unit tests against all of those and produce a report for you, so that you can check that the behaviors are as expected. There's a full help file. You can switch between task lists and a view of the open models. You can validate your session data, and you can save. Once these models have been deployed, saved, updated as according to your wishes, they can be distributed around an organization and set up inside of XLfit as either the default or a user selected model file, depending on how you wish to work. So here is where you specify the main model file and the main statistics file. So if you've edited or created your own model and statistics files, you would simply require an installation that the users choose the correct corresponding folders for these. These could be either share, managed centrally, or managed locally on the machines. Or the users can create their own UserFit model, user statistics file, or you could deploy those as backups to the ones provided by AWS. Thank you.